Microwave Landing System, or MLS. It gets its name from the part of the frequency spectrum that it uses. While the VHF-UHF bands of ILS have the capacity for only 40 channels, the microwave bands of MLS can easily accommodate 200. With MLS, the current problem of frequency congestion can be eliminated, and future landing systems can be assured discrete channels. With ILS, large antennas and large areas of clear terrain are needed to generate a precise guidance approach path with low frequency waves. The broad signal characteristics of these waves make ILS more susceptible to interference and signal reflections. Man-made structures such as hangars or natural objects such as mountains can cause reflections that distort the guidance signal received by the aircraft instruments. At many runways, removal of these obstacles requires costly site preparation, making ILS unfeasible. In contrast, the higher frequency microwaves are produced by smaller antennae. They form very narrow guidance beams that can be more easily controlled to overcome problems caused by obstacles. The conventional ILS is composed of a VHF localizer antenna, which provides fly left, fly right guidance information along the center line, a UHF glide slope antenna for fly up, fly down guidance information, and two marker beacons for discrete distance indications. Together, they form one single narrow approach path. All aircraft, regardless of size or approach speed, must line up, sometimes 10 to 15 miles away, to enter and fly this straight approach to the runway. Compare this with the MLS coverage. The azimuth antenna provides up to 60 degrees of precision guidance along either side of the runway centerline. The elevation antenna covers up to 30 degrees for varied glide slope angles, and distance measuring equipment provides range information throughout this entire coverage area. This precisely coded volume of airspace permits a wide range of flexible approach paths. Flexibility now impossible with ILS. This range of MLS glide slope angles will permit all aircraft to make approaches tailored to their own flight characteristics. Helicopters and short takeoff and landing planes can use the very steep angles within the range of MLS, while airliners can take segmented approaches, flying longer at higher altitudes over noise-sensitive areas, and then closer to the runway, make their more gradual final approach. The broad azimuth coverage of MLS can be used to guide aircraft along curving, winding river approaches, another way to avoid noise-sensitive areas.